Hi students, welcome to physics classes. Now in the last lesson we have discussed uniform motion and non-uniform motion. Now we have discussed it there. Uniform motion, velocity of the body is constant, so no acceleration is required. In non-uniform motion, velocity of the body is not constant. Acceleration is there for the body. If a body moving with non-uniform motion, acceleration is there. Now the question is, what causes the body coming into motion? From rest to motion and motion to rest. Rest to motion and motion to rest. Why? Now if a football to get into motion, if football is at rest, to get into motion, we should kick the ball. We should apply a force on it. Now to throw the ball upward direction, we need to apply a upward push on it. We need to apply an upward push on it. So upward force we are doing. Now here the body coming into motion from rest, we need to apply some force. Force is an external agent here. Force is an external agent. Now if a ball is coming in an inclined slope, inclined plane, to stop the ball, we need to apply a force against its motion. To body stop, we need to stop the body or to retard its motion. We need to stop the body or retard its motion. We need to apply an opposite force. Here force what we are applying, it is an external agent. Now the force here needs contact. Now to throw the ball upward or to kick the ball or to stop the ball, we are applying a force. That is, with the contact we are doing. So here contact is needed. And sometimes we may not require contact. For example, a magnet pulls the magnetic materials or any other magnet by having some distance. Without touching, it can pull. And if you drop any object certain height, it reaches the ground without having contact. Now gravitational force need not any contact. Magnetic force need not any contact. Now here to apply force, simply we can say contact is not needed. Either with contact it can apply force, without contact it can apply force. Now here based on motion of the bodies, Aristotle is a Greek thinker given a statement. What he given? Now to move the body in uniform motion, one must apply continuous force on it. What he said? To move the body in uniform motion, one should apply a continuous force on it, he said. And he given one example. A boy is pulling a toy car with a thread. To move it, he should apply continuous force on it. If he leaves the thread, toy car come to rest. If he didn't leave the thread continuously, he should apply force. To move the toy car continuously, he need to apply force on it continuously. If he didn't apply force, it coming to the rest. But unfortunately, it was wrong. He need not to apply continuous force on it. To prove it, Galileo's given some experiments that we will discuss now. Now, Galileo did experiments on inclined planes. Now, here, if an object leaves up on an inclined plane, it is coming down and it is accelerates. It accelerates That is because of gravitational force. The body which is coming down on an inclined plane accelerates because of gravitational force acting on it in the same direction. Now the same ball, if sent upwards on an inclined plane, sent upwards on an inclined plane with certain force. Now here it is, as it is going up, gravitational force is acting down so that it retards. Now if the body coming down on an inclined plane accelerates, that is because of gravitational force acting on it in the same direction. Now the same ball going upwards on an inclined plane retards because gravitational force acting on it in opposite direction. Now accelerates because of gravitational force. Retards, that is because of gravitational force. Now if a body moving on a horizontal plane, there is no reason to increase the speed or to decrease the speed. So here Galileo concluded that to move a body in uniform motion, in a horizontal plane, we need not to apply force. If the body moving, it continuously moving. If the body moving on horizontal plane, it moves with uniform motion in straight line. Because there is no reason to increase the speed, no reason to decrease the speed. So we need not to apply any force. Previously, Aristotle said to move the toy car with the thread, the boy continuously applying force. There is a frictional force opposing the motion of the body. In Galileo's experiment, there is a frictional force that is opposing the motion of the body. It is also a force, no? It is opposing the motion. So it is also an external force. To overcome this frictional force, that boy is continuously applying force. That boy applied force equal to frictional force. So net force is 0. No need to apply any force to move the body in uniform motion. Okay. Now again, Galileo did another experiment. Now we will discuss that. This time, Galileo has taken double inclined planes. Here, Galileo has taken double inclined planes. Now, both sides same slope he has taken. First experiment, both sides same slope he has taken. Now, if he leave the ball here, it is coming down and its acceleration increases and it will goes to the again same height. Here he has taken smooth surfaces. Now here friction is not totally eliminated. So that it reaches nearly less height compared to here. It reaches nearly less height. If friction is completely eliminated, it reaches to the exactly equal height. What he did, he has taken double inclined plane with the equal slopes, and he left a ball here and it comes down and reaches again to same height, a little less than. In real life, friction is there, so that it is little less than actual height. Okay. In the second situation, he has taken here same slope, but coming here less slope compared to first one. Here it has less slope. So again he left the ball at same height. It reaches the ground down and again goes to the same height. But here to reach the same height, it traveled a little more distance. So by finally body, whatever the height it travel here to down, same height it tries to reach. To reach the same height, here it traveled more distance. Now next, the third one he has taken, there is no slope. When he leave the ball here, it comes down and it travel with a uniform velocity. It reaches uniform velocity. Okay, actually, in a real life conditions, after traveling some more distance, it is getting stopped. Why it is getting stopped? That is because of frictional force. Frictional force is also an external force, no? If that external force is not there, if friction is completely eliminated, it travel continuously with uniform velocity. It travel continuously with uniform velocity. Again, we can conclude that to move the body in uniform velocity, we need not to apply any external force. Okay, if external force, frictional force acting on it so that it is coming to rest. If we completely eliminate the frictional force, it won't come to rest, no. It travel with uniform velocity. So here finally we can say that if the net external force is zero, if net external force is zero, body is at rest, continues to remain at a state of rest. Body in motion continues to be in state of motion. Body at rest continues to be in state of rest. If the body is in motion, continues to be in state of motion, uniform motion in straight line. This property of the body is called inertia. This property of the body is called inertia. Meaning of inertia is resistance to change. Resistance to change. If the body in the state of rest, resistance to state of rest, continues to be in state of rest. Body is in motion, continues to be in state of motion. Inertia, resistance to change. Okay, he given about inertia. This law is known as law of inertia. What it is? Law of inertia. What is law of inertia? If the body, if no net external force acts, if no net external force acts on a body, if the body is at rest, it continues to be at rest. If the body is in motion, it continues to move in uniform motion in straight line or uniform velocity. Okay.